Okay, so we're going to look at compounds. So far we've just been talking about elements. So an element is something that you would find on the periodic table. It's a pure substance. So hydrogen is an element, sodium, lithium, potassium, gold, silver. Those are all individual elements. So going from 1 to 118. If you ever have two elements bind together chemically, we call that a compound. So here, if I highlight, we have an element plus an element will yield, this little arrow here is a yield sign, so it's kind of like an equal sign, a compound, okay? And we're gonna get into two different types of compounds. When we're looking at the structure of molecules, okay, so backtracking a little bit, a molecule is a combination of atoms. So if you have a single element all by itself, like if you just had oxygen, okay, an oxygen atom, just an individual one, O, okay, that's called an atom. But if you have more than one atom bound together, we call that a molecule. So we're getting a little bit more complex. So if you have two oxygen atoms bound together, you would have a molecule. So here, this is an oxygen molecule. We also have a water molecule. So water, the formula for it, you might know it, is H2O. Okay, so what this means is that you have two hydrogen atoms and one oxygen atom. And if you were to draw what the molecule might look like, you would have your single oxygen atom and then two hydrogen atoms. Kind of looks like Mickey Mouse. Okay, so this is H2O, okay, and that's a molecule as well, okay. Here, this is showing you a more complex molecule of table salt, which is sodium and chlorine. This is glucose, okay, which is carbon, hydrogen, and oxygen all bound together, so it's a more complex molecule, okay. So two terms that we need to know. Diatomic molecules. Di means two, okay, in science. So what we're saying is diatomic, two atoms, okay, and that will make up a molecule. So these are all examples here. Diatomic molecules are often found in nature in pairs together. And so a common example is hydrogen. Hydrogen gas, the atoms of hydrogen gas don't like to be by themselves. They most often like to pair up with another one. So we have H2. Okay. Another example that's common, it's a common diatomic molecule or element, is nitrogen. Nitrogen also doesn't like to be by itself. So it's most often in a pair. So it's two. So you have two nitrogen atoms that make a molecule. Okay. Some other types of molecules that we have are what are called polyatomic molecules. Poly, also in math and science, will mean many. So what we're saying is we're having many atoms together to form a molecule. So a real common one that you'll also see a lot of in grade 10 is sulfur. So this is sulfur here. Sulfur, the element, doesn't like to be by itself. So most often when we find it or when we're working with it, we already know and have gathered this information as chemists that it will actually sit around in a group of 8. Okay, so S8 is that there are 8 sulfur atoms all together. And if there's more than two, if there's many atoms together, we call them polyatomic. Okay, so this is a polyatomic molecule, many atoms together. Okay. One important thing that I haven't really gone over yet is when you look at something like O2 here, so that's oxygen. Okay. This 2 down here, okay, is what we call, you need to know, subscript. Okay. So it's a subscript. So the smaller numbers at the base down here, okay, are called subscripts. And what they mean is that they represent how many atoms you have, okay, of that element. So here it's showing me that I have 2 oxygen atoms, okay? If I were looking at sulfur, S8, the 8 is telling you that you have 8 sulfur atoms together, okay? If you looked at potassium, it's not normally like this, but if I had potassium's a unique one where the symbol is not the same as the first letter of the name. So K is potassium, it's found in bananas. And this 4 is telling you that you have 4 potassium atoms together, okay? An ion. So what's an ion? In our Google Meet, we talked a little bit about this as a group. If you didn't attend, please start attending. It's just a chance for us to chat and talk about some things of interest and do a little bit of a review if you ever need. So what an ion is a charged atom. So a charge is either positively charged, or it's negatively charged. And so when we have atoms, okay, they can be either positively charged or negatively charged, meaning they've either gained an electron and they're more negatively charged, or they've lost an electron and they're more positively charged. And so if an atom or an element gains or loses an electron, we then call it an ion. Okay, so if you have an element and it's charged, it's lost or gained an electron, we then call it an ion. We won't just say atom anymore or element because it has that charge. So ion means that you have an atom that is electrically charged. Okay. The term ionization is a process of either gaining electrons, becoming more negative, or losing electrons and becoming more positive. Okay, so how that works is if we look at lithium, and I'm going to post a periodic table with ion charges. The ion charge is typically going to be found on the top right-hand corner of the tile. And it's going to either be +1, +2, -1, -2, maybe +3, okay? And so this charge, what it's saying is that most often lithium actually loses an electron and becomes more positively charged. That's what most often happens with lithium. And your periodic table will represent what's most common. So how that atom, that element, interacts with other things most often. So looking back at that Bohr model and how we draw atoms, if I draw lithium, lithium is the third element on the periodic table. So it's going to have 3 protons in its nucleus. And generally, it'll have 3 neutrons as well. So this is what the nucleus would look like of lithium. Then lithium, okay, most often will have 3 electrons as an element. Okay? So with the Bohr model, you always will have only 2 electrons in this first valence, in this first ring. Okay? and then it's full. Okay? So that third electron has to sit outside of the first ring in its own separate ring. Okay? So it's pretty lonely out here. Okay? So this is that third electron. Lithium does not like this. Okay? It doesn't like just having this one free floating electron. Atoms and elements most often want to have full rings. Okay? So they either want a full ring of 2 as their first ring, or a full ring of 8 in the second, and then 8 in the third. If an element is not full with electrons, they're often going to want to chemically react with something else. So in lithium's case, because it has this one free floating electron, it is most often going to try and find another element to take that electron off its hands so that it can just sit pretty with its full first ring of electrons. Okay? It would rather lose this electron than try and maintain that ring that's almost empty, okay? Because that's nowhere near having 8 electrons. So lithium often will lose that electron. Okay? It'll give it away. Okay? So that electron has gone somewhere else and it'll react. Okay? So overall, if I look at the charge of lithium, okay, if I look at all the subatomic particles and their charges, right now I have 3 protons. Okay? 3 protons. Don't worry about the neutrons because they don't have a charge. But then if I look at how many electrons there are now after I've lost this one, after lithium's given it away, lithium will only have 2 electrons. Okay? 2 minus. So if I have 3 plus protons minus 2, so 3 minus 2, you should be left with plus 1, right? 3 minus 2 is 1. So lithium overall, as an ion, having gained or lost an electron, it is actually going to be overall charged. It's going to have an overall charge of plus 1. It's going to be more positive. It has more protons in the nucleus than it does electrons orbiting. Okay? So that's what this plus 1 represents. If you continue to look throughout your periodic table, you'll see that there is a charge for every element, or almost all of them actually. So what I'm going to get you guys to do is, with the periodic table that I have posted, I would like you guys to identify and tell me what the charge of all these different elements are. What's their ion charge? So what do they most often do? Are they gaining or losing electrons? Are they more positive by 1 or 2 or 3, or more negative by 1 or 2? Okay? So I'd like you to complete this, and then next week I will post the answers. Okay? I'm going to have another screencast video about ionic and molecular compounds that I would like you guys to watch tomorrow, or you can just watch it consecutively after this one. Okay? Have a great day.